Good morning, sir.
Good morning.
Good morning, sir.
Good morning.
So today we shall start change of state. Anyone having any doubt, anything to ask? Yes? No doubt. Then we shall start change of state. So in the first part of calorimetry, we have seen how much heat will be required during rise in temperature, or how much heat will be rejected when any object loses its temperature or drops the temperature or falls the temperature. So when there is fall in temperature, what will be the amount of heat rejected? During rise in temperature, what will be the amount of heat required or given to the substance? Now, there is another case also, that when there is change of state, when solid changes into liquid or liquid changes into vapor. So when solid changes into liquid, what we call this process? So this process is called melting. So that is melting. So melting is the process in which solid changes into liquid at constant temperature. These all we have done in 7 and 8 class. So you are supposed to know all the things. So that process we call melting. And the constant temperature at which this takes place, that we call, what we call? Melting point. Now reverse of this process. When liquid is cooled, then at a particular temperature it will convert into solid, and that process we call freezing. Okay, so opposite of this is freezing or solidification. And the temperature at which this takes place, that we call freezing point. So which one is more, melting point or freezing point? Which temperature will be more? Yes? Which one will be more? Yes?
Both are equal.
So both are equal. At what temperature ice will melt into water? At the same temperature, water will freeze into ice. So numerically, melting point and freezing point both are same. So melting point and freezing point both are same. Well, definition is different. Numerical value will be same. Definition is different. This is the temperature at which solid changes into liquid on heating. That is a constant temperature at which solid changes into liquid on heating. Whereas this freezing point is the constant temperature at which liquid changes into solid on cooling. So that is melting point and freezing point, value is same. Now, this melting point or freezing point is affected by, so melting point of pure salt, pure ice is constant, that is 0 degree at normal pressure. So melting point of any material depend on, first is its nature. That is, this material or this object is made up of what material, what substance. So its nature. Nature mainly means what are the molecules present, what are the atoms present, what is the molecular distance, intermolecular space, or atomic distance, what is the force acting between these two atoms or these two molecules, whether the force is loose or whether the force is strong. So that will decide the melting point of any substance. For example, pure ice will melt at 0 degrees Celsius. Wax melts at nearly 40 degrees Celsius. Naphthalene melts nearly at 80 degrees Celsius. So that is the melting point of that material. That depends mainly on nature. Second is atmospheric pressure also, or the pressure of the environment. In which environment it is heated. It affects, so atmospheric pressure or pressure of the surrounding, whatever it is, so that also affects melting point. It always also depends on impurity. So if some salt is mixed in ice, its melting point decreases. Melting point will become nearly minus 15 degrees Celsius. In case of pressure also, if pressure on the ice is more, its melting point decreases. These all effects we have already done in class 8 in detail. What are the substance whose melting point increases? What are the substance which melting point decreases? There are some substance whose melting point increases with pressure. Oh, here in case of ice, it will increase. Okay. So these all effect already we have done discuss in class 8, so no need to discuss again here. Now another process is when this liquid is further heated, what will happen? At certain temperature, it will boil. So that process we call boiling. If it is not boiling, then also at all the temperature, liquid changes into its vapor, and that process we call
Evaporation.
evaporation or vaporization. Okay. If it is taking place at constant temperature, then we call it boiling point. That process we call boiling, and the temperature we call boiling point. There is no evaporation point. Liquid can evaporate at any temperature. So evaporation point is not there. Mainly in our syllabus, this melting is there. Evaporation is now removed from the syllabus. So we will discuss only this melting and freezing and how much heat is required. That main purpose is here. Melting and freezing process we have not to discuss here. That already we have discussed in class 8. Suppose we are taking this, during the determination of this melting point of wax. In class 8, we have seen this experiment. So some wax is taken in the test tube. One thermometer is also inserted. This experiment we have not to see, only we have to understand what is the meaning. So when we are heating it, what happens? The temperature will start rising. At a particular temperature, this wax starts converting into so when the temperature reaches at the melting point of the wax, which may be 40 or 42 degrees Celsius, this wax starts converting into liquid. Now we keep on heating, but there is no change in temperature. Suppose it has come to 42 degrees Celsius, and after that it is not rising. The temperature is not rising. But we are constantly heating. Why this is happening? What does it mean? We are heating, we are giving the heat. Heat is transmitted to the wax, but then also there is no rise in temperature. So it appears that
The heat energy is
heat which
absorbed
we are
in changing
keeping-
the state.
Yes. So it appears that whatever heat we are giving to this, it is lost. It is not doing its work. Generally, when we are giving heat to any substance, there should be rise in temperature. But at this stage, we are constantly giving heat. When you remove the burner, this wax will not melt. Once it has increased, reached to the 42 degree, and after that you remove the burner, will it melt? No. We will have to keep on heating. So we keep on heating, but then also there is no change in temperature. So what does it mean? So it appears that heat is lost. So whatever heat we are giving during this change of state, that heat only we call lost heat, that is latent heat. The name is latent heat. It appears that heat is lost. Actually, there is no loss of heat. Whatever heat we are giving to this substance, to wax, at this stage, that heat is used to increase the intermolecular distance. The molecules are separated. So when intermolecular space or distance goes beyond certain limit, then only it will change into liquid state. So during change of state, whatever heat we are giving, that is used to increase the intermolecular space, and that heat is stored in the form of potential energy. When you elongate the spring, you will have to do some work. So whatever work we are doing, that is stored in the form of potential energy. When you compress the spring beyond its normal position, if suppose this is the normal position of the spring, you increase this, you will have to do work. You compress it, you will have to do work. So while doing this elongation or compression, some energy is stored in the spring, and that we call potential energy. So here also the intermolecular force is like spring-like force. So when you are elongating it beyond certain limit, it will increase, potential energy will increase. When you are compressing it beyond limit from the normal position, again energy is stored. Okay. So during this change of state, whatever heat is given to the substance, it is used to increase the intermolecular space and is stored in the form of potential energy. Now, as you know, the temperature is what? Temperature we said is the average kinetic energy. And here there is no change in kinetic energy of the molecule. That's why there is no change in temperature. So this question, reasoning type question, frequently it is asked. During change of state, we are giving heat or heat is given to the substance, but there is no change in the temperature. Why? So how will you explain? Here. So just to write what will be so during change of state, why there is no change in temperature, though we are giving heat constantly. So during change of state, why there is no change in temperature, though or even not after giving the heat also, or whatever the language may be, though we are giving heat constantly or heat is given after giving heat also. So how will you explain? So during change of state, whatever heat is given, during change of state, whatever heat is given, it is used to increase the intermolecular space of the molecules and is stored in the form of potential. As temperature is given by average kinetic energy of molecules therefore there is no change in temperature. Okay, so this will calculate here and it is stored in the form of potential energy. Here something more you will add. And there is no change in kinetic energy of molecules. After that, this last slide. As temperature is given by average kinetic energy of molecules, therefore there is no change in temperature. Same will be case during freezing also. So whatever heat we are giving during this change of state, that heat we call latent heat. So another term is latent heat. So latent heat is, it is the amount of heat required to change the state at constant temperature. Amount of heat required to change the state of any substance. So it may be solid to liquid, liquid to vapor, whatever it is. So there are two types of change of state. So two types of latent heat will come. What will be the unit of this latent heat? So it is the amount of heat required. Naturally, it will be joule. SI unit of latent heat is Joule. So this latent heat will depend on how much mass of the object is and what is its nature. To melt ice, heat required will be different. To melt wax, heat required will be different. To melt iron, heat required during melting will be different. So mainly it will depend on, so this latent heat first is mass of substance or mass of object, and second is nature of material. So what material is used, whether it is wood, whether it is iron, whether it is ice. So what material is used, so it will depend on nature. Amount of heat depend on three things. One was mass, other was nature, and third was what? Change in temperature. And here there is no change in temperature. During latent heat, no change in temperature. So it is the amount of heat required to change the state, keeping the temperature constant. So temperature is not changed here. So that's why only these two factor will come. Now, if we want to remove this factor, that is mass, we are giving one more term. We are defining specific latent heat. So another term is specific latent heat. Means it is latent heat under specified condition. And specified condition is what? The mass should be unique. That is the case. So naturally it will depend only on nature of material. So there are two types of latent heat. Two change of state is there. One is melting, another is evaporation. So specific latent heat again will be of two types. Latent heat will be, so we call specific latent heat of fusion or melting. or freezing, meaning it's same. During freezing, heat will be rejected. During melting, heat will be absorbed. Magnitude will be same. Now this one is specific latent heat of vaporization or evaporation, whatever. So in our syllabus, this one is not there. We have to discuss only this one. Concept is same. So whatever concept here will be, same will be applied there also. Or any competitive exam, if you are preparing NTSC or any other, you have to see that type of numerical also. So same concept is applied. So how we define this? So it is the amount of heat required to melt unit mass of given substance at its melting point. So it is the amount of heat required to melt unit mass of given substance at its melting point. Whatever the melting point of that substance may be, when we reach up to melting point, during reaching the melting point, amount of heat will be required, and that will calculate by ms theta by that formula. But this is only during melting. What will be the situation during melting? If melting starts, then temperature will become constant. And during that constant temperature only, whatever heat we are giving, that is specific. For unit mass, it will be specific latent heat. So this we give the symbol L. So here L may be F we are writing, and here we are writing LV. And in our syllabus only one thing is there, so L means this freezing only, LF only, so no problem. So specific latent heat is what? Amount of heat required for unit mass. So this specific latent heat will be amount of heat required during amount of heat required, you can say, during melting. Or if you are interested in this one, then it will be or during evaporation. By mass. So during, so what will be the unit? So it is amount of heat, that is joule per kg. So SI unit of specific latent heat, L is joule per kg. And it depends only on nature of material. So it will be very easy to learn the value. Otherwise, for 5 kg ice, different latent heat. For 10 kg ice, latent heat will be different. Here it is specific latent heat, means for unit mass, what will be? For 5 kg, this much heat, then for 1 kg, how much heat? For 0.2 gram, this much heat, then for 1 kg, how much heat? So always we will express in terms of 1 kg or 1 gram only, maybe unit. What are the other units? Other units may be calorie per gram, joule per gram, kilocalorie per gram. So these all may be like this, or kilojoule per gram or kg, whatever it is. Now, from here we are getting another formula for, so the amount of heat lost or gained during change of state will be this into this. So one formula during rise in temperature we have got there, and this is the another formula, only two formula, whole calorimetry chapter. So amount of heat lost or gained during change of state. Change of state means when temperature is constant and you are giving the heat. What will be? This Q will be M into L. So during change of state means temperature is constant. So here there will be no change in temperature. So during constant temperature, amount of heat required will be mass into specific latent heat of fusion or vaporization, whatever it is coming. So it will come like that. So only two formula will be there. That is, one will be mass into specific capacity into changing temperature, and other is mass into specific latent heat of fusion or melting or vaporization. What vaporization, if it is not there here in syllabus, so ourselves only latent heat of fusion will come. Okay, so we'll leave up to here.